Okay, hi guys. So today we'll be solving Leetcode problem escape the spreading file. So we are given a 2D integer of grid of sign m plus m multiply n, which represent a field. So 0 represent grass, 1 fire, 2 is a wall that you cannot pass through. So we are currently situated in the top left cell, and we want to travel to the bottom right cell. So every minute we may move to an adjacent grass cell. So after you move, then every 5 cells will spread in a 4-directional way, right? So we need to return the maximum number of minutes that we can stay here, right? We can stay here before moving, and while still safely reaching the safe house. And if this is impossible, then return -1. And if we can always reach the safe house regardless of the minute stay, and return 10 to the power of 9. So there's one edge case here. If the pie spread to the safe house immediately after you reach it, it will be still count as safely reaching the house. What do I mean by that? What do they mean by that? So okay, so the fire spread after each minute, or after you do a specific activity, right? If you move here, then the fire will spread in the 4-directional ways. And if the fire spread here and then you move here, right, and that will still be counted as so you will still be counted as safely reaching the safe house. That's what the edge case about. And the intuition to solve this problem is just come right into my mind, right? Use binary search with the boundary or from 0, which means we move immediately after jumping into the field, to 10 to the power of 9, which is the right bound, right? And how can we conclude that for state we can safely come to the safe house? We use basically a parallel breadth first search, right? One for the fire and one for the human. And that's just basically it. I'm pretty sure that my intuition has got better after months of doing Leetcode, and I can actually start to solve some hard problems without looking at the hint. And it just come very natural, right? Okay, so you can take a look at some of the test case here. We can see that after letting a fire spread for 3 minutes, you can actually still move to the safe house. Okay, so we stay here for 3 minutes, the house spread, the fire spread, and then we start moving, and then we can still come to the safe house. If we let the fire stay in the start position for 1 more minute, we can not have any ways to come to the safe house. Here is an example when we cannot come to the safe house even if we start immediately after jumping into the field. Because why? Because when we come here, okay, let's say we come here or come here, right? There are 2 ways the fire will spread in 4-directional ways. It cannot spread to the walls, but it can spread here and spread here, and it will basically burn us no matter what position we are in, right? So here is one case where no matter how long we actually stay in the first position, we will still be able to come to the safe house. Because why? Because the walls block all of the way that the fire can reach to, right? This is contained by walls, the only fire here. Okay, so basically I will have three function, right? View state function to actually mimicking the state of the current field if we stay there for n minute. The can pass is to basically define, like to conclude for a state we can reach the safe house or not. And then the maximum minutes is basically just a binary search function, right? So we can start by saying left and right is equal to 0 and r multiplied by c, yr multiplied by c, because if we do 10 to the power of 9 here, it will not be as efficient as we do r to the r multiplied by c, which basically means that if the file spreading, the most minute that it can take for it to spread the whole field is actually r to the power r multiplied by c, right? It spread one cell by one cell, it will take r to the power c. And then we can check if, okay, if cell can pass cell view state for grid, and then the minute passed by 10 to the power of 9, we can return 10 to the power of 9, right? Okay, so now we are going to write our binary search function. Yl smaller than r, mid is equal to l plus r divided by 2, right? And then if cell can pass cell view state mid grid, grid mid, right? Grid mid. So then okay, now we actually can still reach to the safe house at midpoint. So we are going to just negate half of the search space by moving L to mid. Else, okay, so at this midpoint we cannot reach the safe house, right? We need to negate half the search space and then just remove this midpoint entirely from our search space, right? R equal to mid minus 1. At the last step, we need to okay, so now we are at L. L now could be 0, right? But even at 0, we still cannot reach the safe house, right? And then in that scenario, we need to return minus 1. So we need to do one more checking at the end. If cell can pass cell view state grid and then L, we just return L, else we need to return minus 1. And that's it for our binary search function. Now we need to come to the build state function. Okay, the build state function, basically we need to mimicking the state of the field after we stay there for some number of minutes, right? Okay, so we need to make a copy of the current grid. New grid is equal to row for a row in range. Okay, so let's say that RC is equal to n grid 0. Range R, right? Okay, now to do a BFS, we do BFS for the file only, right? Q collection BQ for R in range R, for C in range C. If new grid RC is actually equal to 1, which means 5, right? Then Q, we append it to the Q. Then for after each minute pass, we need to actually spread the files in a 4-directional, right? So if Q not else, just break. This is to ensure that after reaching a level of minutes, right, there will be not any file left in the queue, right? We need to break it to make sure that it is efficient, right? For example, if we go up to all the way to n to the power of 9, then there is some point where there's nothing left in the queue, but this is still executed, right? So we need to make sure that if there's nothing in the queue, we need to break it. Okay, so for I in range len q, the current row and column could be equal to q the top left, and then for er dc in 0 1 1 0 0 minus 1, and then minus 1 0. Then the new r and new c would be r plus er c plus dc. And then if 0 smaller than r, smaller than r, and which basically mean that new row and new column is still inbound, right? And with new r, and this is basically if this is a grass, right? We will append it into our queue, and then we can turn it into a file to avoid revisited, right? And that's basically it. That's the build state function. Okay, you can actually try to make sure that it works correctly, right? Self new state, self new state grid, and then 3 for r in range r, print new state r. This is new grid. Oh my god. Okay. Invalid syntax. Okay, this is it's pretty lengthy in implementation, so list index of range. is this. Okay, so as you can see here on 3rd-minute marks, you can see there's 4 files on the first row, 3 files second row, 4 files on 3rd row. Yeah, I think that's good enough, right? Let's say that it's good enough, right? So now let's try to write a function to determine if we can still pass the safe house for a state, right? So we need to pass in the new grid. Okay. How are we going to do it? This way, and then a Q for human, right? Zero zero, and a visited for human to avoid revisited cell multiple times. We are currently at 0 0 index, right? Okay, so in range R. Basically this file, we append it to Q. Okay, so now what are we going to do next? We are going to do basically a parallel breadth-first search, right? We will do breadth-first search for the human guys first, and then the breadth-first search for all the files later, right? Because as you can see, the file spread after we move, or after each minute pass by, that we stay in the same position, right? Okay, so now y human q, it's gonna be hard, right? For I in range len human q. It's going to be human q pop left. Okay, so if the human row and human column is actually r-1 and c-1, and then the new grid is not fire, right? It's actually 0. We can say that return true. Okay, and then for just going to copy paste this. If this is inbound, and not been visited, and it's actually grass, right? We can append it to the human queue. It's going to be really lengthy, right? Let's see. Okay, so that's a human part, right? So now come to the file part. C is equal to Q the pop left. Just basically this. Okay. I think that's good enough, right? And after exhausting the queue, we can simply return false. But basically there's one edge case here, but let's see if we can run it. Grid is not defined. Okay. Okay, so that's the edge case that I'm talking about, because here they say that if the file spread to the safe house immediately after you have reached it, it will still be counted as safely reaching the safe house. So that's exactly what happened here, right? So a file spread here, but then we immediately jump into it, so it still count as reaching the safe house safely, right? Okay, so you can create a variable called just reach. Could be immediately set to false, and then if r, we say that if r is equal to r minus 1 and c is equal to just reach equal to true. So basically the same here, right? Oh my god. And r is equal to r minus 1 and c is equal to c minus 1. We can also say which reach is equal to true. And then in here we can say that if hr is equal to r minus 1, hc is c minus 1 new grid, hr hc is equal to 0 or just reach, right? We can return true, and then we can set the variable back to false after we're doing it, right? And just reach false. Just reach. That's basically can take care of the edge case, hopefully. Oh no. That doesn't? Where did I mess it up? It's insane. Insane amount of code. It's really hard to debug. Oh my god. So annoying. We reset here. Return -1. Oh, that's here. Return 0. That's crazy. Must have been wrong somewhere. Oh, here. Fuck, still wrong. Okay, so if we encounter a 1 at the bottom right corner, we set just reach to true, and now we come here. If we can safely come to the safe house, right after that we return true, and then else we just reset the state of just reach to false. Same here. Damn, son, I don't even know. Fuck. That's why these type of questions are really hard. Right? It's really hard in implementation because there's no way to debug. Let's say 4. What the hell? What's the fucking difference? I can tell the difference, guys. Okay, let's stick with it. I don't know. Okay, so that's basically the answer for this question, and as you can see, it's not really efficient. I try to do as much optimization as I can, but okay, so let's say there's some room for actually improvement here, and as you can see that we are rebuilding the state for each search, right? Here for each midpoint we are rebuilding the state, but we can do better. Let's say that if we have a cache or two for each state, right? So now if we come in, now we have a new midpoint, we can actually say that what is the closest point that we have in cache that is closest to this state, right? And then we can start populating from there. That could be much efficient, but it will also be very lengthy in implementation. Okay, so overall the time complexity for this could be a log of n, not n, but rc, r multiplied by c, and then for each of these we need to rebuild the state, right? And that's actually another r of c. Okay, space complexity basically the same. Why? Because we are rebuilding the state for each iteration, right? Okay, personally I would say that this problem is actually the hardest in implementation. No, not hardest, but above the hardest. Just after some like annoying question like translating the amount of money to English, or some stack problem like yeah, after some annoying stack problem, this basically just also really annoying, right? As you can see, but the approach is actually really intuitive, right? It's just coming right into your mind if you practice enough amount of binary search question or breadth search question. Actually the solution is actually intuitive, right? Okay, so that's it for today. I hope you guys understand the solution, and see you guys in next video.